welcome to Easy Elim Learning Simplified. My name is Ruth, and the topic for today is gas laws. So, we are going to be working on Boyle's law. We are going to discuss the Boyle's law, and then we are going to do some few practice questions. So, Boyle's law states that the pressure of a fixed mass of a gas is inversely proportional to its volume provided that the temperature is kept constant. So the thing that we have to note here is that the temperature is being kept constant. So what we are changing is the pressure and volume. So if you look at the formula from the law, we have said that the pressure is inversely proportional to the volume. So if we introduce a constant in this formula, it's going to be P. When you introduce a constant, you remove the proportionality sign, and then you introduce the constant times 1 over V, which gives us P is equals to K over V. If you want to be left with constant one side, we multiply by V and multiply by V. That brings us to P, V is equals to constant. If we look at the graphs of pressure against volume, you notice that the graph that we get is usually a curve. So when we say that the pressure is inversely proportional to volume, if we pick a specific point on the graph, you can use the graph to explain the law. Let's say we pick a specific volume. If we interpolate that specific volume on the graph, and then we pick another point also that is increasing, for example, and extrapolate. You notice as we move from point A to point B, that volume is increasing, but as you move from point A to B, when you look at the pressure, it is decreasing. So because point A had a higher pressure and then point B had volume B had a lower pressure. So it goes opposite. When the pressure increases, the volume decreases. When the pressure increases, when the pressure decreases, the volume increases. So also the graph of pressure against the inverse of volume, it will give a straight line, and pressure PV against a constant will give a continuous line. This is happening because it's against a constant. So the pressure of a gas is a result of collisions of particles with the walls of the container. So this is just using the kinetic theory. So when we talk about pressure, we are looking at the collisions or how the particles are hitting on each other and at the walls of the container. So if we reduce the volume at a constant temperature, the molecules will not have enough distance to cover before colliding. So the collisions will become very frequent because they're not covering a bigger distance. So if you look at this image, for example, you see if the volume is increased, these particles have a bigger distance to cover because before they collide with each other and the walls of the volume. But if the volume is decreased, you see the pressure increases because these particles, their collisions with each other and the walls will increase gradually because they are not covering a larger distance. So that's how Boyle's law is explained. So let's look at some examples. So at 27 degrees Celsius, nitrogen has a volume of 650 centimeters cubed and a pressure of 980 millimeters per mercury. What would be its volume at the same temperature but a pressure of 760 millimeters mercury? So let's note down what we have been given first of all. So first of all, we have temperature. The temperature we have been told is 27 degrees Celsius. And then we have the first volume, you'll call it volume 1, which is 650 centimeters cubed. And then we have pressure 1, which is 980 millimeters mercury. And then what would be the volume? So our volume 2 is the question at the same temperature. So the temperature 2 is going to be the same, and the pressure is going to be 760. So when you look at the Boyle's law, we said it was PV is equals to constant. So let's improve on this formula. So if we take more than one pressure and volume, that like we did on the graph, our conclusion is the P1 V1 will always be equal to P2 V2 because it is equals to the constant. This is the same as taking P1 V1 is equals to constant, and P2 V2 is equals also to constant. Remember, constant and constant will remain the same. So it is okay for us to combine these two. So this is the formula we are going to use to do our calculations. So let's look at what we have. We have our pressure 1, which is 980. We have our volume 1, which is 650, which is equals to our pressure 2, which is 760, and our volume 2, which we do not have. I like to put V2. So let's do this calculation. So 980 times 650 will give us 637,000 is equals to 760 V2. So we want to divide 760 both sides. So it means it's 637,000 divided by 760, which is going to give us 838.158. And remember, this is in centimeters cubed. So that is going to be our answer. Let's look at another question. A volume of 375 centimeters cubed of a gas has a pressure of 20 atmospheres. What will be its volume if pressure is reduced to 15 atmospheres? So first we start by writing the formula, which is P1 V1 is equals to P2 V2. We identify what we have been given, a volume of 375, that is V1, which is 375 centimeters cubed. And then P1 in this case is 20 atmospheres. And then what will be its volume? So V2 we have not been given if the pressure 2 is reduced to 15 atmospheres. So we want to put what we have in the formula. So we said P1 V1 is equals to P2 V2. So our P1 is 20, our V1 is 375, is equals to our P2 is 15, and our V2 we do not have. So this tells us that it's going to be 20 times 375, which gives us 7,500. This 7,500 is equals to 15 V2. So you divide both sides by 15, both sides by 15. So 7,500 divided by 15 gives us 500. So our V2 is equals to 500, and remember it is centimeters cubed. So that's our answer. So next we look at another question. At a constant temperature, a gas at 540, so the pressure, now we have pressure 1, which is 540 mmHg, occupies a volume, so this will be V1 of 300 liters. The gas expanded to occupy a volume, which is our V2, 600 liters. What is the new pressure? So P2 is what we are looking for. So we said the formula is P1 V1 is equals to P2 V2. So our P1 is 540 times our V1 is 300 is equals to P2, which we don't know, times 600. So this is going to be 540 times 300, which is going to give us 162,000 is equals to 600 P2. We divide by 600 both sides, you get 270, which is equals to P2. So this is going to be 270. Always remember to put it in the right units before you submit your answer. Let's do one more last question. So the volume of a given mass at 25 degrees Celsius, toast temperature 1 is 25 degrees Celsius, and the volume and the pressure 1. So add 750 mmHg. So pressure 1 is 750 and volume 1 is 564 centimeters cubed. What will be its volume at temperature 2, which is 25 degrees Celsius? You see it's constant, and volume 2 is what we are looking for. Pressure 2, we have been told, is 760 mmHg. So we said it is P1 V1 is equals to P2 V2. So our P1 is going to be 750, our V2 is going to 564 is equals to P2, which is 760 times V2. This tells us this is going to be 750 times 564, which gives us 423,000 is equals to 760 V2. So we divide by 760 both sides by 760, which will give us 556.579. And remember, this is volume, so you put centimeters cubed. That brings us to the end. So in the next video, we are going to be looking at Charles' law. So see you then.